Anyone, for number 1, you had 3 parts. Anyone want to try one of the parts? Nature? You pick whichever one. Go for it. Do we agree or disagree with Nature's answer? You should agree this was the right answer, whether you did everything algebraically or just put it in your calculator, either or. F of 2 equals -7, or you can write it as f of x equals -7, either or. Anyone want to try B? Or I can do it. Okay, so same thing, we would put -4 in for x. And then figure out what that would be. So I'm going to actually just do all the work. 3 plus 20, so 23. So f of -4 equals 23, or f of x equals 23. Anyone want to do C? And then same thing, but here this would just become 0. So this would just become 3. So f of 0 equals 3, or f of x equals 3. The biggest thing with these is knowing what you're given and what you have to solve for. These said f of some number, so that was x. You were finding y. Questions on any of those? Anyone want to do 2? Same thing. You were given g of some number, so that was your x. So you're trying to figure out when x is 3, what is your y value, which is 1. So g of 3 equals 1. There's really no work for you to do. You're just kind of matching the lines together. Questions on that one? 3, I'm going to do for you in the calculator. Remember that you could do this in the calculator in Desmos or by hand. You do need to set up each one. So let's do that. So the first one, we put -2 in for all of our x's. So this would be 1/2 times -2 squared minus 3 times -2 plus 1. And then the next one would be similar, but now with 3. And then the last one would be similar, but now with 8. So you could do each of these by hand or in your calculator separately. I'm going to put them all in together. So in my calculator, I'm going to go into y equals and clear out whatever's there. Type in my function alpha y equals 1/2 x squared minus 3x plus 1. Go into my table, second graph, and then I'm looking for 3 values, -2, 3, and 9. So -2 I see, I'm sorry, 8, not 9. -2 is here, so when x is -2, y is 9. When x is 3, y is -7/2. And then when x is 8, y is 9 again. So because our domain was given in curly brackets, we would need to also put our range in curly brackets, least to greatest without any repeats. So we would have -7/2 and 9. Sometimes your domain and range numbers, amount of numbers don't match up, and that's okay. Questions on that one? Did anyone try 4? I'm not going to go over it just because that one is more challenging than the others. If you could do 1 through 3, then you're fine. I'll talk you through the basis of what you had to do for 4, but we're not going to actually do it unless someone wants to see it. For number 4, because we have some k value in here that we don't know, and they tell us h of 1 equals -5, you would put 1 in for all your x's, put -5 in for y, solve to find k. Then after you find k, you would go back and answer what is h of -4, put -4 in for all your x's, and find y. So it's like multiple parts, more challenging than something we would probably do. And I doubt you would see something like that on the S1. Okay. Questions on that before we move on? Okay. So, in the event that we don't have school tomorrow, then I wouldn't see you on Friday, which means you would lose your flex day. If that happens, you need to come see me. Well, of course, we won't know if we don't have school until later, but on a just in case, I would say if you need to finish a test, you need to come see me after school today or Friday morning. Otherwise, I'm grading them as is, as I had already talked about. Friday, you were going to have time in class, but if we don't have school tomorrow, you won't have that time. There's nothing I can do about that. Questions on that before I say something else? The other part, if we're not in school on Friday, we're supposed to draw names. Would we rather draw names today on a just in case we're not in school Friday? So those in favor for drawing names today. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's more than half. Okay. And then one last thing. So not today, but moving forward when we draw names, would we rather do repeats so like people who won before can win again, or still wait for everyone to have been picked before repeating? So those 4 repeats, raise your hand. Of course, those that won already would say that. 1, 2, 3, 4, 5. Those that rather everyone get it before we repeat. 1, 2, 3, 4, 5. I need a tiebreaker. 6, 7. Okay, so then we won't do repeats. Okay. So later we'll draw names and things like that. I'm going to have you guys start writing this because it's a lot. Today is the last lesson in this unit, which means when we get back, we'll be quizzing and testing, but we'll review and things like that before that. So the words are kind of small. I tried to make them bigger. Don't feel like you have to write all of these also. So I'm going to read them, summarize it, bullet point it, write what you feel like you need to write. You don't have to write it all. So the definition for our intercepts, and you may know this already, for your x-intercept, graphically, it's the point or points where the graph crosses, touches, or intersects the x-axis. Algebraically, it's the point or points at which y or f of x is 0. So algebraically, the graph has to cross, touch, intersect the x-axis. Algebraically, y is 0. The definition for your y-intercept is very much the same, except the opposite, I guess. For your y-intercept, graphically, the point or points where the graph crosses, touches, or intersects the y-axis. Algebraically, it's the point or points at which x equals 0. So graphically, it crosses, touches, intersects the y-axis. Algebraically, x is 0. You'll need to be able to know those and keep them separate. You don't have to write this entire sentence, but you need to know that intercepts, anytime you write them, should be written as ordered pairs, so x comma y in parentheses. And then x-intercepts have other names, just like domain and range. They're interchangeable. You don't need to write all of this, as long as you know that x-intercepts are also called roots, solutions, and zeros. That's really all you need to know from that sentence. So I'm going to explain the why as why they're called that, but you don't have to write this part, and the bell's going to ring in like 20 seconds. So when we get to quadratic functions, we'll be talking about roots. We were just doing solving, where we solve for a solution, made the equation true, and then zeros, if we put it back in, it would make it true. So let's start with number 1. We are given a graph, so we're going to start off by finding x and y intercepts graphically. I'm going to outline my x and y axis. You don't have to do that, but if it helps you see, do that. And then we need to find where does that line cross the x and y axis. Plot the point there, and we're going to list them as ordered pairs. So what would our x-intercept be? Where does that cross the x-axis? Nature? 2. How would we write this as an ordered pair? That would be that. What would the y-intercept or the y value of this point be? 0. So just 2 0. So we should not be putting the x and y intercepts together in the same ordered pair, because that wouldn't be an x or y intercept. How would we write the y-intercept? Lily? 3 or negative 3? Negative. Questions on that? So this is really just look at the graph. Where does your line or function cross your x or y axis? Write it as an ordered pair. Don't write them together. Let's do the same thing for 2, but your 2 is different than my 2. Ignore my 2. Look at yours, because you all have the same one. I don't. Pretend mine is yours. Where does it cross the x-axis? There are 2 points. Give me just one of them. Go ahead, Cameron. So how would we write that? 1, 0. And then the other? Negative 2. How would we write that? So depending on the function, you could have 1, you could have 2, 3, 4. It really depends on what the function looks like. And then y-intercepts. It's like halfway between 2 points, so make up a decimal. What would the y-intercept be? Pauline? Sure. So how would we write that? Just like that. So y-intercepts and x-intercepts can be decimals depending on where it is. You may or may not see that. Especially on Khan Academy, you'll probably see that more. Questions on that? Nature?
Just for the Khan Academy,
it will want you to put it in as fractions. And then you'll be able to see what that fraction would be. I don't think you'll get fractions for the graphs. I think they'll be more so for the equations, but we'll talk about that here in a second. All right. Reviewing some of our previous material. Is number 1 a function? Yes, it passes the vertical line test. If I ask you, what is the domain of number 1, what would you tell me? I'll just write the opposite side. What about our range? What would the range of number 1 be? Hannah? Because it goes left and right, up and down. If I ask you the same thing for 2, imagine this has arrows, or yours has arrows if it doesn't already. What would the domain, backtrack. Is this a function? Yes, it passes the vertical line test. Yours should also pass the vertical line test. What is the domain of number 2? Think about the arrows. What does that mean? What is our furthest point to the left? Lily, what were you going to say? Yes. Because this keeps going left, down, and right. So our domain is all real numbers. What about our range? And look at your range, not mine. What would that range be? Hannah?
Is the line thing, and then 1.5 is greater than y.
You could write it that way, y, or write it the other way. Y is less than or equal to 1.5. Those would mean the same thing. Okay. Just refreshing so that we don't lose that information. Can't really do function notation here unless I pull out a specific value, which I'm not doing. All right. Questions on how to find our intercepts from a graph? If not, move on to the next page. We're going to do 2 different formats of algebraic. This will be one, and then we'll come back and do another. So we're going to do 2 of these, 1 and 4, where we have to find our x and y-intercept of both. So for our x-intercept, our y value is always 0, so we have to put 0 in for y. So if you want to, you could rewrite this as y equals 4x minus 8. You don't have to, it's just if you want to. That way you know what we're putting 0 into. Because we're looking for our x-intercept, our y value has to be 0, so I'm going to replace y with 0. And now we'd have to solve for x, so this is very similar to our function notation, just specific values. How would we start solving this? Victoria? And then to get x by itself? Go ahead, Victoria. So we'll get an answer, but we still need to write that as an order pair. You also need to list which one it is, because you could write it correctly, but I don't know if you know if that's the x-intercept or the y-intercept. So label it And then how would we write that as an ordered pair? We have our x, we put in y, use those two numbers. Lily? Would it be 0, 2? Would it be an x-intercept? 2, 0. So your y value is always going to be 0 when you're finding an x-intercept, no matter what. For your y-intercept, now we're going to put 0 in for x. So whether you leave that f of x or y doesn't matter. But we're going to put in 0 for x. What happens when we do that? Victoria? And we get, okay. So what is our y-intercept? So we would write that as 0, -8. Notice that the -8 is the same number that's a constant in your function. If your functions are set up this way, f of x or y equals some number in front of x with a constant at the end, that constant is going to be your y-intercept no matter what. Some of you may remember that from slope and things like that, and we'll talk more about that later in our next unit. So if it's in this format, you don't have to do the work for the y-intercept. You do have to do the work for the x-intercept because you can easily see what the y-intercept is. Question on 1 before we do 4. Before we find our x-intercept, someone tell me what the y-intercept would be. By looking at the function. Lily? Tell me the whole order pair. 0 would be your x, yes. Victoria, what were you going to say? Look at that last number. That'll tell you what your y-intercept is. Okay. Now we can find our x-intercept by doing the work. So again, you can change this to a y, or you can go straight in and change that to 0. So we would add 6 to both sides. How would we get rid of the 2/3? Teacher? Take it, flip it, multiply by the reciprocal, so 3 over 2. What would your x value or x-intercept be? Lily? Write that as an ordered pair. What would that be? X-intercept is 9. How would we write that as an ordered pair? Victoria? 0. Questions on how we find x or y intercepts algebraically in this format? We're going to do, I'm going to show you how you would do this in the calculator. If you were given any function, you could find the x and y intercepts in the calculator. We're going to do 2 in the calculator and 7 in desmos. So if you don't have desmos open, you could just follow along. But the calculator I want you to do with me. So for number 2, go into y equals, clear it out if there's anything there. Put in that function. Someone tell me what that function was. Well, what did it say for number 2? I know it's 5x squared, then what? And the last part? So after you have this in y equals, you're going to graph it. So hit graph. You may or may not, depending on the function, be able to see your x-intercepts and y-intercept. It depends on the function. So if you can see them, you can automatically write what it is, what it says. But sometimes your graph looks like it's on the right thing, but not. So I'm going to show you how you could know for sure. Alex?
How would it change it to equal?
If you see something that's not equals, reset your calculator. 2nd plus 712. And then go back in and type that in and graph it. It's number 2. Once you have your graph in, we're going to go into second trace. And which of these do you think we're going to go into? Lily? Not quite, because this is where 2 lines would intersect. Intercept and intersect are 2 different things. The second one, 0, is another word for x-intercept. So that's what we're going into. 2. When you do that, it's going to ask you for left bound. So you can only do one of these at a time. So let's say I'm trying to figure out, is this actually at -3 or not? I want to pick a number that's to the left of this. Any number works. -4, -5, any of those. So pick one, type it in. Let's say I do -4, and then hit enter. A line should appear. It's saying it will not look past that line. Then it'll ask for your right bound. You need something to the right of this that doesn't go past this one. So any of these numbers in here work. -2, -1, 0, 1, any of those. So let's say I choose -1. I would type that in and hit enter. Now we have another bar that's saying the calculator will only look between those 2 places. Then it wants you to guess, but we don't want to guess. We want the calculator to do the work. So hit enter again. And it'll tell you what that 0 is. You would just have to write it as an ordered pair. Yes. So if you missed that, we're going to do it again, but find the other one. So you have to go back into second trace. Back into 0. But now we're looking for, is this actually at 2 or is it like a decimal? So we need something to the left of this that doesn't go past the other one. Someone give me a number that would work. What's a number that would be left of -2 but not past -3? I'm sorry, left of 2 but not past -3. Matthew?
-1.
Sure. type that in, hit enter. Now we need something to the right. So someone choose a number that would be right of 2. Matthew. Sure. Now we have the bars that the calculator is going to look at. I'm going to hit enter again, and it will tell us what that x-intercept is. So if you got a problem like this, you would say that you did this in the calculator, and then you would still write down your x and y-intercepts. We haven't done the y-intercept yet. Questions on how we find the x-intercept before I show you how to do the y? These would be more so for problems like something with x squared, x to the third, x to a higher power other than 1. Because you could solve to find the ones that have 1. You should be solving the ones that don't have an exponent. You just don't know how to solve these ones yet. For your y-intercept, we're going to go back into second trace. For your y-intercept is different because now we're looking at a value, a specific value. So go into 1. If we're looking, yes. If we're looking for a y-intercept, what would our x value be? Try again. 0. So put in 0, hit enter, and it'll tell you what your y-intercept is. So 0, negative 30 would be our y-intercept. Yes, you can write it as. Questions on how to find x or y-intercept in the calculator? Number 7, I'm going to do in desmos. If you have it up already, you can follow along. If not, when you're practicing and want to be able to do this again, just ask me and I can show you. So in desmos, this is number 7. You would just type it in like normal. It would graph it for you. If you click on it, all of your x and y intercepts will highlight. You just click on those points, it'll tell you what they are. So we can write down all of those. -1, 2, and 4 for our x-intercepts. And then our y-intercept was at 8. Did it work? Isabel, make sure you're back within 10 or less minutes. Questions on how we do that in Desmos? So once you have your function in here, it graphs it for you automatically, and then you just find where it crosses the x and y intercepts axis to find the intercepts. Okay, we're going to do one last thing, and that's finding intercepts algebraically from a different format. Find this page. We're going to do 1 and 4 in this format, you're going to need to do the work for both the x and the y. But the rules are the same. If you're looking for x-intercept, you put 0 in for y. If you're looking for a y-intercept, put 0 in for x. So if we were finding our x-intercept first, we would put 8x plus 3 times 0. And then proceed to solve. So this would give us 8x plus 0, or just 8x equals 24. Divide both sides by 8. What is your x-intercept as an ordered pair? Victoria? Notice that I didn't write x equals 3. Once you get the hang of this, you can start skipping some steps, not all of them. But you don't have to write x equals 3 and then go back and write 3, 0. You would do the same thing for your y-intercept, but opposite. So now we're going to put 0 in for x and solve. After you put the 0 in, if you want to, you know that this is going to be 0, so if you don't want to bring that down and just go to the next step, you can. If you want to still put plus 0, you can also do that. It does not matter. Divide both by 3. What is your y-intercept as an ordered pair? Nature? Now, in this problem, our x and y-intercept happen to be the same numbers that were here in our problem. That is not always the case, so make sure you do the math on it just in case. Sometimes you'll get fractions, so like the ones you'll see on Khan Academy, some of them will be fractions. You just leave it as a fraction. Simplify it, leave it as a fraction. Questions on this? We're going to do one more, and then you'll have time to practice. For number 4, it does not matter for all of these if you do the x first or the y first, as long as you do both. If I was finding my x-intercept and I put 0 in for y, what happens? That would be your x-intercept. Now, generally, you shouldn't get big numbers if like you're starting off with smaller numbers and you get a really big number. Something's probably wrong. But in this case, because 56 was already in the problem and our y term disappeared, that makes sense. So just double check your work. Let's do the same work for our y-intercept. Put 0 in for x. Solve for y. What is our y-intercept as an ordered pair? Hannah. 0, 8. Questions on number 4? In these, 11 and 12 are very much like what we were doing before. On the back of this, you don't have to turn to this. We're not doing this until a later unit, so don't worry about that. Look through all of the pages. Find any questions we didn't do that you want to see, go over, have questions about. If there's something in the calculator, something on desmos, algebraically, graphically, any of that. Nature. I can get it. You said 17? I think this is the right one. My numbers might be off though. Oh, no, it's just numbered weird. Okay. I didn't number those. I don't know why I did that. Yes, Izzy.
Okay, he's back.
Go ahead and make yourself a pass. It's loading. I'm trying to. Here we go. Right, 17. You want to do this in desmos or the calculator? Okay. We're going to put 17 into the calculator. So go back into y equals, clear that out. Someone read 17 off to me, please. Where's your going?
X plus e minus 2x minus x plus 2 plus 2.
Izzy, go ahead. Be back within 10 minutes or less. Once you have your function in the calculator, go ahead and graph it. If you can see it, say that again, sorry.
It's 2x squared.
Like that.
Yes.
Okay. That changes a little bit. If you can see the x and y intercepts clearly, you don't have to do what we were just doing. If you wanted to double check, you could. But I can see that this is at 1 and 2 and -1 for your x-intercepts. It doesn't say on here to find your y-intercepts, but it's good practice. Find it anyway. I already forgot all of these words. -1, 1, and 2. My y-intercept looks like it's at 2, but it also looks a little off, so I'm going to check that one. By hitting second trace, going into the value, number 1, and putting in 0, and hitting enter. It was at 2, I just want to make sure. Also, even with these problems, it's still in that format, f of x equals something, something, something with a constant at the end. That constant would still be your y-intercept. Any other questions we want to see, go over, have questions about before you have time to practice? So, you guys have different options on what you can be working on for the remainder of class. If you haven't done the 2 Khan Academies that are due on Friday, you can work on those. If you've done those already, you could start the 2 Khan Academies that are due in January. Again, don't wait until January, but the information is fresh in your mind. You could get it done now. You could keep working through this set of notes packet, working on different problems. You also have the review within all of your papers that you could start working on as well. So pick any of those to be working on. You guys can work with each other, move around. Let me know if you have any questions.